In this session, we're going to take a deeper look at a type we've already been using extensively, optional. We'll gain some powerful knowledge which will boost your ability with enums and switch pattern matching. Then we'll go on to look at two essential flow control keywords that are quite unique to Swift. Let's start with optional. We've been using it for some time now, and hopefully you've become quite comfortable working with it and are starting to use expressive syntax. Now that we've covered a few more topics, we're ready to look deeper at optional, and with it learn a lot more about enums. So now you'll see why we occasionally refer to optional with title-cased typed name syntax. Optional is itself a type, a generic enum with an associated value for one of its cases. In fact, the question mark and exclamation mark operators are really just compiler syntactic sugar that makes optional more pleasant to work with. You should still use them, but understanding the underlying implementation of optional will gain you a lot of power. Here's a reduced interface. The enum optional is generic, with the generic placeholder named wrapped. This is the type of the optional. Let's swap that for a concrete type to make the meaning clearer. So you can see that there's an initializer for an optional with a string value. There's also a case in the enum called sum with an associated value of type string, or whichever generic placeholder type the optional has. This represents the state of an initialized optional with a real value, the associated value. Therefore, is the real value contained inside the enum box. There is also the other case none to represent a nil enum with no value. Of course, the case none has no associated value because it has no value. Now that you know the true implementation of optional, you can start taking advantage of this, and also learn more about the power of enums and extensions. Let's look at some simple examples. We've already used the nil coalescing operator to use a default value with an optional. This covers the case where the optional is nil or has a value. If it's nil, we can provide a default value. This is a nice, safe construct we can often use. Now let's consider a similar but slightly more complicated case. We're interested in a conditional where the optional has the value nil or has some particular value. We could write something like this. We aren't interested in accessing the value, we just want to do something if it's nil or has a particular value, in this case foo. We can't use the nil coalescing operator here because we're interested in the case where the optional is nil as well. Instead, we need this full expression, and we end up using the force unwrap operator on the right hand side. Not very elegant. Now that we know that optional is a value type, could we express this more formally and in a reusable way? Of course we can. We can extend optional. Let's add the following method. It's called isNone or value. It's a generic method using the optional's placeholder wrapped. It should return true if the optional is none, nil, or if the optional has some value equal to the value argument to the method. Let's start writing it. Since optional is an enum, it makes sense to use a switch statement for such a method. Optional has two cases, some and none. Let's start with none, the simplest. Of course, if the optional is none, nil, we just return true. Next, the case sum. This is where we'll use the associated value ourselves for the first time. When we write the case statement, we can access the associated value like this. This gives us a normal value. Then inside the case statement, we just do an equality comparison. Done. We have extended optional and given ourselves a much nicer convenience method to use, isNone or value. Exploring and implementing features such as this will start pushing yourself into mastery of Swift, really understanding how the language works. But there's more. So in this section we're going to look at the actual implementation of optional. So I'm going to access that implementation interface from the playground. I have an optional var here which is an optional string. Now in order to look at the implementation of optional, I need to change the type of my var. We're going to discover that the optional question mark is just syntactic sugar, and that optional is in fact a full type in the standard library that we can explore. So I'm going to change the type to optional with the generic placeholder string. And once I have a full type in the playground, I can use jump to definition to see the full implementation or the full interface of optional in the standard library. Now the implementation is reasonably long, but we're interested in just the beginning of the interface here, where we have the fact that optional is an enum with two cases, case none, case sum, and the initializer with a sum value. You can also learn about optional